வாய்ப்பு கவனித்து சார் இந்த வாய்ப்பு கவனித்து வெரி குட் ஆஃப்டர்நூன் ஆல். ஸ்டார்ட் பண்ணுறீங்க சார்.
Good afternoon, Babu sir.
Good afternoon, sir.
Sir, can we wait for 2 more minutes, sir? Actually, some people have to join
Okay, sir.
with your permission.
Yeah, no problem,
Thank
sir.
you, sir.
Good afternoon, everyone. It gives me immense pleasure to welcome on behalf of Sri Venkateshwara College of Engineering, Tirupati, Triple E Department. And now AICT sponsored 1 week short-term training program on research trends in renewable photovoltaic system and its research challenges phase 2. So before going to start the session, here are some instructions to follow them as usual. So, all the participants are requested to mute your microphones and turn off your cameras. And all the participants are requested to pin the resource person screen and listen the session and note down the key points. And also post your queries in chat box during query session. All the queries will be answered by the resource person. And now it is my heartful welcome to our beloved HOD, Dr. Sudhir Kumar sir, department, who is always being with us in every occasion held in this campus.
PV thermal one. PV thermal, that is hybridization of PV as well as the solar. So how we are going to happen and what are all the possibilities of a PV thermal system. And second one is PV and wind. This is also one of the research topics where there is a problem over the integration of the grid. Okay. Next, PV and fuel cell. Hope everybody knows the fuel cell. This is also one of the major renewable energies which will generate the electrical energy in a sufficient way. So, in this presentation, I am going to handle generally on PV thermal. Just I will introduce the what is the PV and wind and PV and fuel cell. When it comes to PV and wind, hope the diagram itself it is saying that which is having the PV array and a wind system. So the both the systems will currently develop the DC to DC or AC to DC according to the converter design topology. We can make conversions and then we will store with the batteries, and with the help of charge control we can supply the load. Okay. One of the major research problems, okay, when it comes to PV and wind hybridization, the imbalances in the power ratings and the grid stability for this end process is one of the major topics. The people who are working in the area of hybrid PV and wind, this is the two research problems which the people are dealing currently. And then when it comes to PV and fuel cell, okay, the fuel cell, the input for the fuel cell is the hydrogen gas. Okay. So with the help of the PV, in the air we will collect the hydrogen, and with the help of hydrogen tank generate the electricity. The combination of both PV and the fuel cell will generate the combined DC power. The fuel cell is output of a DC, so that the DC power generated by the fuel cell and the DC power generated by the PV will combinedly supply the load with the help of the converters. Okay. So there are a major problems on fuel cell is the temperature. Okay. When operating the PV cell is, fuel cell is operating, which will develop the process of electrolysis will develop the heat in turn, and this heat will lead to damage of many systems. So one of the major drawbacks in the fuel cell is heat and the extraction of heat, starting and stopping of fuel cell operations. This is also one of the complicated study. The people and the fault prediction of the fuel, in which way it is going to be happen. The fault is happened in the fuel cell it is not easy to identify. The people who are working in the area of fuel cell, if the system is not working properly, means what is the cause for the damage? Okay. Because if a fuel cell, 100% efficient fuel cell, 100% commercial fuel cell, which will give say 2 kilowatt means, okay, after 10 years, the fuel cell will generate the 1.9 kilowatt. The reduction for the efficiency is 1.9. Let us take it. It is a 0.1 kilowatt. Okay. So what is the reason to decrease the energy? Okay. Because the people who are working in this area are clearly observed and they making the research. Okay. What will be the parameters which influences the efficiency and energy generation individually? Okay. The people overall says the efficiency of the fuel cell. But the thing is, what is the individual impact? That is one of the major research topics. Recently, there are published in the major journals. If anybody interested in the area of fuel cell, you just go through that one. Okay. Finally, my topic is PV thermal. Okay. As I said, PV thermal means it is a combination of both PV and the thermal energy. So which will combine the two different technologies. Okay. That is the input for the PV thermal is sun only. Okay. And one of the image which is showing how the energy is coming and what are all the energies we are wasting in the solar module. Okay. That is the PV module. Okay. If we consider the solar energy is coming from the sun is 100%. I'm taking just a value. If whatever be the radiation I'm getting, take that as a 100% means, which will radiated back as 10%. Okay. And the modules absorb, okay, either the glass, either the silicon wafer, either the backsheet, anything will absorb only the 5% of energy. Okay. Then it will come back to the remaining 10 plus 5, that is 15%, 100 minus 15, which will back to the PV layers. Okay. and then it is also 5% will refracted back and 5% is absorbed. Okay. So in this one, we are only collecting the 45%, but it is losing the 35%. Okay. And everybody knows the PV module manufacturer data. Okay. Because every institution is accommodating the PV modules on their rooftop. Okay. If everybody has any clarification regarding this one, you just go through that one and check how the manufacturer is giving the data sheet. Okay. In this data sheet, they will give the open circuit voltage, short circuit current, and power coefficient of temperature coefficient of power or temperature coefficient of voltage or temperature coefficient of current. Okay. Either in these three, they will specify either temperature coefficient of power or temperature coefficient of voltage or temperature coefficient of current. Okay. This is the parameter which shows the buyer or else which shows the customer such that after every 1 degree rise of 25 degrees centigrade, that is, we have I think the PV module which is tested at STC, that is standard testing condition is 1000 watt per meter square and 25 degrees centigrade. This is the standard testing value, that is, I repeat, 1000 watt per meter square and 25 degrees centigrade. Okay. So these two are the inputs for the PV panel. So if we are seeing the data sheet for the STC conditions, the majority or 98% of the PV modules is having the negative temperature coefficient. Okay, which means the majority of the PV modules will generate or will loses the amount of power generation by increasing the temperature after every 25 degrees centigrade. Okay. Guys, the room temperature of India we are as the 27 degrees. Okay. Means there is a 2 degrees centigrade in normal. Okay. Because the tested one is 25 degrees. But the room temperature in India we are seeing as a 7 degrees. That is, if we install the PV panel by the temperature rise, by the normal temperature itself, it is losing the power. Okay. Hope you got the point. The problem is we have a PV module, but in the PV module itself, it is operated at the 27 degrees centigrade, but by the operating temperature, the PV module losing its energy. Okay. So my objective is why we can't make a single module which can either it may extract light and heat energy. Okay. Or else it may convert. Okay. Heat energy is also converted back into heat energy. If that is a possible one. Okay. So for that one, I made this diagram. Okay. For easy understanding. What are all the technologies we have? How we are going to operate. Okay. General term is the solar energy what we are getting by the PV cells, we are converting to as a electrical energy. Okay. This is a normal one. Okay. The second one is also a normal one. There is the thermal energy which we receive from the solar thermal modules, which will generate the thermal energy. That is, hope everybody knows the solar water heater. Okay. In the solar water heater, we can extract the sun radiation and heat. Okay. So that we can see the easy difference. Okay. Next, in the recent trend, the hybrid cells is a combination of both PV and the solar. So the thermoelectric generators, hope everybody knows the thermocouple. Everybody knows the thermocouple. Okay. Thermocouple means if there is a temperature difference between two junctions, okay, there is a hot junction and the cold junction, will lead to the potential across terminals. Okay. That is the principle of thermocouple. Okay. If I make around n number of thermocouples in a single place, there is a thermoelectric generator. Okay. There is not much developed material thing. Okay. The bismuth telluride is a recent advanced material which will make the thermoelectric generator as a feasible for the renewable application. Okay. Hope everybody knows the I think DLR. In a car there is a continuous rain of LEDs. Okay. So this is the amount of energy supplied to that LED railing is fed with the thermoelectric generator. Because of there is a lot of developments in the material science, it can make it feasible for the conversion of thermal energy, that is low grade thermal energy into as a efficient electrical energy. Okay. To design or else to make any kind of the PVT system, we have a three major parameters. First, we have to select what kind of collector type we are choosing. Okay. The second is whether we are using the coolant or not. Okay. And what kind of PV material we have. Okay. Guys, if you want to select efficient PV system, any PVT system, PV thermal system, we have three major parameters. The first parameter we have to select is which collector type you are going to use. The second one is whether you are using the coolant, which type of you are using. Okay. The third one is which type of PV material you are using. Okay. So in this image, I have a several parameters. You can find a single one. I mean, you can find a paper or you can find any source from the first. They will select a collector type as a flat plate. They will select a water as a liquid. They will select a monocrystalline as a warm thing. They can make the simulation and the hardware. They will publish a paper. So this is one kind of work. You can change one parameter over here. You can select one parameter over here and the coolant type as another parameter and select as a PV material as one means it is with a completely different work. Okay. There are many kinds of research work which we have which is a specified with respect to these three parameters only. Okay. You can find many PVT systems. Out of that many PVT systems, all are classified with respect to these three parameters. Okay. The first one is collector type. Okay. As I said, many of the rooftop systems, there is whenever we can accommodate in the roof of E1, there is a flat plate is the best suitable one, and the concentrated is the. I hope everybody is seen there is solar thermal configuration. What I showed my previous. Okay. So this is a concentrated line. Okay. The mirrors which are projecting the total radiated energy to the concentrated pipe. Okay. So similar manner, there are a tarot type, dish type. Okay. There are many types. They are also they can make the projection over one surface such that the total energy is stored or accumulated in a single place. There we can extract that energy in that place. Okay. So in that there are three different types. That is a parabolic screw and the press lens and dish type. Okay. The majority of the research work is on concentrated type only. Okay. When you are going to see any PV thermal system, you can see 80 to 90 works on concentrated type only. Why? Because the people are concentrated extract the large amount of heat rather than the low heat application. When it comes to concentrated type, we can concentrate on a single surface which will collect the large amount of heat to useful form of energy is a quite easy concept. So the people majorly concentrate on concentrated type rather than the flat plate type. Okay. When it to coolant type, okay, the PVT systems using the coolant as a water, there is you are calling as a liquid type. Okay. And the nanofluids, there is the recent trends in the nanoparticles, they can extract refrigerant. We can extract the large amount of heat, or else we can store the large amount of heat by using the nanofluid. And then other things, that is the thermoelectric generators, all those comes under the other. And the gaseous things. Okay. There is the gaseous means we can use the best concept of PV thermal is air only. Okay. Similarly, when it comes to the PV material means if we choose the one type of PV vapor which will work for one thing, okay, which will change the overall performance. Okay. If I select a crystalline, if I select a silicon type, okay, the majority ones are silicon types only. Okay. In the silicon type, we have a two types, that is a crystalline and thin film. Okay. In the crystalline, we have a mono and poly. The regular one, okay, the majority of the market, energy market are manufactured in the monocrystalline and the polycrystalline rather than the remaining. These all are, okay. Only few things is operated on these things. Okay. Only few industries are operated on remaining these. There is amorphous silicon and the multi-junctional one. And when it comes to non-silicon also, cadmium telluride, copper, indium dicyanide, copper, indium, gallium, lead, and they recently we have a disenfranchised solar cell. That is which is the structure of the disenfranchised solar cell is quite different than all the structures. And recently also Photovoltaic cells, okay, which will come out of the thin film structure. Okay, this is also one of the revolutionary technology which made the PV. Okay. So first, my objective is why we are not seeing a single module to extract light and heat energy. So for this objective, I need a single module in my rooftop such that it can extract both light and heat energy. So I made my object as a specified one. Okay. So similarly, if you made this object in a specified one, you can select flat plate. Okay. There is a lot of resource scope for the flat plate. Okay. Because the concentrated types are majorly focused on, I think the IIT Delhi, the Center of Energy is majorly focused on the concentrated type. Okay. So if you have interest in the concentrated type, you just contact the IIT Delhi, the Center of Energy Research Cell. They are working in a very effective way to get the solutions for the different concentrated type PVT systems. Okay. So when it comes to the PVT design parameters, okay, because whether select water, okay, I selected the water as the liquid, okay, but whether the water is making, in the work you will find whether the water is flowing natural way or a forced way, okay, whether the water is flowing natural or forced, okay. Similarly, whether the air is flowing natural way or forced way, okay, that is the coolant flow, in which way it is flowing. Okay. Whether it is a single pass or a dual pass. Okay. The next one is when it is a single pass or dual pass. Single pass means the input is from one end and the output is from another end. Dual pass means the input and the output of the coolant is same. Okay. That is in a bilayer. Okay. There is a 8 types. You can find the 8 type PVT connections or many types of this dual pass one. Okay. And if you okay, the area in a small things will make the major difference in the performance. Okay. And whether we have glazing, okay, that is in the majority the people are making the concentration on the top layer, that is in a PV surface, in a silicon wafer, there is a whether the glass is single glazing or multi glazing. Okay. Why the people are making the single and the multi glazing? Okay. In a single glazing, the whatever be the optical energy, that is the optical energy which is radiating on this glass surface, we made the lens such that if that energy, whatever be the projecting on the optical lens, which may project on the single surface, will be the more beneficial than the optical lens which is projecting on the overall surface. You got the point? If you make the optical lens which is projecting on a single one, which is making the large amount of energy in a single point. Okay. If you are making the optical lens, making the whole in a distributed manner, it is not possible to conversion into a useful form of energy. So we are designing the glazing such that to get the overall energy in a single manner. So for reason, the people working on with the multi-glazing system. Okay. And in the, hope I will see we have a first top layer is glass, second layer is silicon, the third layer is absorber plate. Okay. There are many types of absorber plates. Okay. First one is the plate material. Which type of plate material we are using? Most probably the people using the aluminum and the copper. Okay. Why? Because the aluminum is having the light weight, which makes the module as a lighter one. Okay. But the people who are making the temperature as a constant one, okay, the temperature of the whole surface making the constant one means people choosing the copper as a best thermal conducting medium. So the absorber plate what they are choosing is copper one, and the round tube absorber, we have absorbers which are tube type structures and flat plate absorbers. Okay. So whether the flat plate we are using or else we are using, okay, the absorber is also making the sense. Okay. Guys, if you are interested to work with the PVT, okay, just if you see in this one, in this slide, you just find out which type of PVT system you are using. Okay, next slide, on which type of structure we are going to operate. Okay, that is the first one is for designing the, first one is to design making the structure. Second one is the in that first, in this one we choose the, but in this one we can finalizing the whether the coolant is naturally flowing or single pass, whether it is a circular or not. So in this pattern we can make the different designs, okay, and can use the novel type of structures also. Okay. So when it comes to generalized things, okay, how we are classified the PVT system. Okay. The general one is the liquid cooling type, that is water and the nanofluid. Okay. So the water is also active type and passive type. Both things are present in water and the nanofluid type. Okay. And the gaseous cooling type, that is air and cooling gases. We have a refrigerant, air conditioning refrigerant. Hope people know R32, okay, R429. we can use the cooling gases also, whether they are flowing in a active manner or passive manner. That is irrespective of the type of design and the point. The other things. Okay, whether we are using with the PCM means phase change material. We can integrate the phase change material. That is, whenever it gets heated, it will store the energy. Whenever it gets cooled, it will extract back the store energy. Okay. So the best example is hydrogen salt. Okay. Carbonate hydrogen salt. Okay. I am not good in PCM. Okay. Next, heat pipe type. The heat pipe what we are seeing is, I think the solar water heaters what we are seeing in India are using the heat pipe. Okay. There is a gas tube structure. In that one there is a heat pipe which will collect the heat energy from the sun and which will give heated. We are using that hot water. Okay. So we can make the integration of heat pipe also with the PVT system. Okay. Next, solar distance cooling. That is, we can use the PVT system for making the cooling purpose also. Okay. Then one of the different area of research. And the final one is by integrating the thermoelectric generator with the PV, which will make the system as a effective one. Okay. Finally, whatever I said, the PVT module. So from this slide onwards, I'm making concentration on only flatless structures. So in the flatless structures, the top layer is always a glass and the plate. The black dots are the silicon wafers. The two gaps, that is coolant in and coolant out, is happened in the observer surface. Okay, the total we are calling as a PVT panel. Okay, so I will say one thing. Okay, till now there is no commercialized manufacturer in India for a PVT panel. Okay, only we have a vendors. Okay, we don't have any manufacturers. We have only vendors. They are purchasing the PVT. That is also in PVT only the two things only commercialized. That is liquid type and the air. Okay, that is water type and the air type is only the two commercialized products till date. Okay, but I showed the many things. Okay, only water type and the air type is only commercialized product for till date. We don't have is many things. We are not seeing these many in a commercialized products. Okay. The major problem is still they are working on the research to get the optimum amount of energy. Okay. I will just brief out how the liquid type of configuration will look like. Okay. So the liquid type configuration is, you just see whatever with the energy which is striking, we can use the water which will close to the back side of the PV panel, which will extract the heat energy and which will pump with the help of pump. We are pumping the water on the back side of the PV panel. This is the liquid type. Okay. And then when it comes to there are many types of the liquid type of applications. The major ones, whatever I shown in this one, the major ones are only three. There is space heating, water heating, and water distillation. Okay. In all the classifications, I shown only these three only. Okay. Space heating means we will heat up the total home, which will be useful for the cold countries, and the water heating. We can use the liquid type by the heated water can be used for the hot water purposes, and water distillation. By using the PVT panel, we can make the distillation, that is the distillation process, separation of unwanted molecules from the unwanted molecules from the dusted water. Okay, we can just purify the water and we will get the pure water from the distillation plant. Okay, so the major applications of the PVT is this one. Okay, when it comes to the, I think I shown one of the A-type configuration. This is the compressor which will pump the air onto the PVT system. This is a dual pass one. Okay, that is the whatever the air we are pumping, which will come to the same compressor unit, which will store the hot air in the compressor unit. Okay, there is a storage tank. Okay, in this compressor there is a storage tank inside this one. The PVT A-type is working on. Okay, I said that there is a single pass and the dual pass. Okay, and there are many glazings. Okay, you just see in this one. Okay, there is an unglazed A-type PVT. Okay, in the second one, the difference in design is only single glass. Okay, in the first case, we have only PV module air insulation. In the second case, we added only the single glass. The design is quite different. Okay, the performance is different. Okay, when it added the double glazing, that is, I added the double glazing. One is a protective glass, another one is an optical glass. Okay, another optical lens. Okay, we will call it as an optical lens, such that which will project the whole energy in a single place, which will beneficial to collectively utilize the heat which we collected in the glass surface. There is a top surface. Okay, the final one is glazed reality, but the pass is dual pass. Okay, this whatever the air can flow in the two things. Okay, between the glazing to PV and PV to insulation. There is a dual pass. Okay, whatever I said for A-type, the first one is without glazing, second one is single glaze, third one is doubly glazed, fourth one is dual pass. Okay, the performance of each one is quite different. Okay, which will varies. The results is also quite, interesting. Okay, if you find out these results, you will feel somewhat these parameters will influence the overall efficiency. Okay, I will say one thing. The performance of this module and the performance of this module is having the 8% efficiency difference. Okay, this if I take, there is a 8% difference if I made the area dual pass. Okay, and when it comes to the nanofluid type, okay, this is one of the nanofluid type structure. In the nanofluid type, we have a nanofluid which is flowing with the help of pump. Okay, so we need a thing for the nanoparticles. This is also one of the things. The design, how we are going to design. Whatever I said, the optical lens. Okay, so I said the structural lens. Okay, the top layer will receiving the whole surface, which will project the whole energy into a single one. Okay, in this place we have a nanofluid nanofluid passing, which will collect the heat energy and will store the heat storage. Okay, this is also one of the dual pass structure. Okay, so the structure which will the design itself is saying that we have a many kind of design structure. Okay, we can make the single design value. We can make any single change in the design which will impact majorly. Okay, when it comes to nanoparticles, these are all the nanoparticles which currently used by the PV thermal area. Okay, so this is completely related to the very strong research such that to develop the many kinds of novel nanomaterials in a recent. Okay, when it comes to PCM based, okay, there is phase change material based. The heat energy what we are presented back to the PV panel, that heat energy can be stored with the help of phase change material. The phase change materials will also use to convert current, which also utilizes the waste energy what we are not used for the any kind of purposes. so that the efficiency of the PCM is also somewhat lesser one. But as compared to the, I mean, nothing is better than something. Sorry, something is better than nothing. Okay, the similar manner, without using the thermal energy, if we utilize the thermal energy for storing, which is a beneficial one. Okay, so for that reason, the PCM is also plays a vital role in the storing of heat energy. Okay. The phase change materials was also classified according to the three different, that is the organic and inorganic and electric. Okay, the people who are working with the PCM is also need more concentrated on the research development. Okay, the final the PV thermoelectric generator one. Okay, that is, if we integrate a thermoelectric generator on the back side of the PV panel, which will extract the more energy. I mean, with the help of thermoelectric generator, it will convert the waste heat energy into as a useful form of electrical energy, which will give the better solution for the among all. Okay, why? Because when it comes to PCM, which is having the less efficiency, when it comes to nanofluid, the design is quite complicated. When it comes to the heat type, we need a separate storage structure, so we need a compressor. When it comes to liquid, we need to operate with the water. Okay, but remaining all those PVT concepts, the best concept we gain more attention is the PV with the thermoelectric generator. Okay, the thermoelectric generator which will generate the electrical energy by the low grade heat energy. Okay, there is a recent development in the bismuth telluride and the bismuth telluride materials, so that it will generate additional energy. That is, the energy generated by the PV and the energy generated by the PEG, which will add the energy to the PV system. So the PVT configurations is also classified into two things. That is what I said in my earlier one is a flat plate and the concentrated type. The flat plate types are generalized one. Okay, that is which is feasible for the rooftop applications, and the concentrated types are which is feasible for the concentrated, which are feasible for the large type of industrial consumers. The equivalent electrical model, that is, if you want to design a PV system, this is the equivalent electrical circuit. This is double diode model from this one. Okay, from this current I, this is the double diode model of the PV, and from this one, that is from DPV, this is the output of the PV, which is the electrical equivalent of the thermoelectric generator. There is a voltage source in series with the resistance, so that we will see the total electrical equivalent of this one. Okay, as I said, the performance of the PV varies with respect to the type of PV layer. Okay, so I simulated the different PV layers. Okay. Finally, I choose a multi-crystalline PV as a best design concept, so that I propose the multi-crystalline PVTEG and I made the comparison. The result shows that the multi-crystalline PVTEG module will develop the additional 8% of energy. Okay, that is, if the PV is having the efficiency of 18% means, okay, by using the PVTEG 8% of energy. Okay, so which is a good result and which will give the strength to make the real time. The first one is design and testing of prototype of PVT system configuration. Okay. The first one is design. As I shown in my presentation, there are a variety of parameters which will influence the overall system. Okay. We have many kinds of designs. Okay. But we don't have a exact testing methodology to make the system as an efficient one. Okay. If we have a FCC PV, okay, but when it comes to this one, there is no exact testing procedure to make this system as a feasible application for the rooftop system. Okay, so the people who are interested to work with one, so they may develop the testing. Okay, next, second one, we are going to test anything. They need a standard. They need a standard of testing procedure. Okay, and to make the performance evaluation, whether on which basis or which standards we are going to develop this one, and the energy policies and safety standards. Okay. Guys, there are many, I mean, as I said, the PV, TEG, whatever is which is giving the additional energy, all the PV systems is also giving additional energy than the PV. Okay. My one question is, I think, as I worked for the 3 years in my research career, okay, I've seen around 300 research articles on the PV thermal system. Okay. The basic question what I asked for everyone is, you show the output as a which is greater than the efficiency of PV, commercialized product. I shown the many of design parameters. Okay. Finally, whether you designed any PVT system, okay, whether it is suitable for application or not. Okay. The best application what I suggest is zero energy building. It is building PVT system. Okay. That is, if we integrate the PV and the thermal system, which will add the extra energy, whether it is sufficient to drive the whole home or not. Okay. There is a building integrated PVT system. Okay. If you made the zero efficient, the zero energy consumption building means that is the best one. I will suggest NTU, National Technological University, Singapore, has developed their research center as a zero energy building. That is, they are not consuming a single watt of energy from any other sources. They are developing their own energy for the whole building. Okay. So if you are working with this one, this is also one of the good research problem for you. I suggest you one of the methodologies what I followed to reach my destination on time. Okay. First, choose the system. Next one, you just make one assumption. Hypothesis means it's just an assumption. Okay. I thought of it will generate the additional energy or not. Okay. That is an assumption. Okay. By that assumption, you just make one research problem. How we are going to make the research problem is by reading many of the research articles, then only it is possible to make the good research. Okay. If you made any research problem, then finalize your objective. Okay. How we are going to finalize the objective means you just make the research and divide into different parts, different concepts. Okay. I made my objective says my first concept is how whether the PV module temperature is sufficient to drive the thermoelectric generators or not. Okay. I made one objective like that. Okay. I worked for the PV TEG. My objective, what I made is whether the PV module temperature is sufficient to drive the TEG or not. Okay. If I say this answer as only to design PV TEG. Okay. So by making one problem, we have to classify or else we have to divide the objective such that to reach our goal in a certain point of time. Okay. And develop for designing any model, just develop a mathematical model. Then only it is possible or it is strong to speak in front of anybody to say this is correct. Okay. For that one, which will develop by the mathematical models only. Okay. And then made a qualitative or quantitative. Either both of the quantitative. Okay. It's a type of guys. Okay. The first one is either you may made qualitative or quantitative analysis. Okay. Then you can develop a good system. Final one is if you get the qualitative results, okay, then go for the prototype. Okay, you just develop a prototype module. Okay, then finally you just verify standards. Okay, if you follow this methodology, you will make the novel PV TEG or a novel PVT system to research. Okay, thank you guys. Okay, this is my mail ID. If you have any clarification doubt which is not clarified in this session, you just reach me over in this mail ID. Okay. Thank you guys. The session is open for queries. Before saying the answers to the queries, I just thank the people who made me to stand in front of you. First, Dr. Kumar, one of my research partners who motivated me in many ways to reach this position. Okay. And Honorable HOD Dr. Sudhir sir for giving this opportunity to present whatever be my work and whatever be the different research areas in the PVT system, and the Honorable Principal sir of SPCE and the AIC members gave the chance to share this knowledge through this online manner. Okay. This session is to queries. Okay. If anybody is having the queries, kindly ask.